Hello, welcome back to CS170 Spring section. Looking at my page right now, you'll see that I've been adding, right? So this is for the week of February 1st. I put in like a little link here for IPv4 versus V6. It's just more for information, and then you have the modules here, right? The week 3 resources. But for IPv4, V6, and I'm going to cover this in a second with the lecture here, really the main thing is just to understand that version 6, V6, is more addressable spaces. And it's really to cover the Internet of Things, right? So there's many more things that are internet accessible, able to connect via the internet. So therefore you need to have a whole bunch of these addresses. So I'll go into that in a second. But there are actually other differences. They're probably beyond the scope of this class. For the scope of this class, you just care about the fact that the difference between V4 and V6 is more addressable spaces. But for those of you that are interested in more information, there's a whole bunch more information about the actual differences. And you can look at that, but you won't have to know that for the exam. So it's more of just for your own bonus knowledge. Okay, so this is where we left off. You remember last lecture we were talking about cookies, how cookies are stored locally on your computer, and they help you to simulate a continuous session with the server computer. So it looks like you're online with your bank and going back and forth with them when you're actually not, right? It's this whole request response thing. I make a request, they're doing that at the same time as spinning around to all the other requests that are coming through and doing different things. But to you, you don't know that. It looks like you just have a continuous connection with the server, and part of how it manages that is with the cookies. Again, we're going to cover more of this later on, but that's the basic introductory concept. Now, IP address for V4, which is probably what a lot of you already have known in the past. I mean, you may not actually punch in these IP addresses because you'll punch in something like Amazon.com or whatever, and I'll go into all of that later, right? But in actuality, when you type in Amazon.com, that actually maps to like a real address, IP address, right? And in this case, you're talking about a series of numbers, right? It's a byte, right? Each one is a byte. And very coincidentally, it kind of matches up to what we were just talking about with pictures and pixels, right? So remember a byte is 8 bits, right? It's a word that's 8 bits, and 8 bits that goes to 255 or 256 characters, right? Because you start off with a 0. So 0 to 255, okay? So you want to say each bit, no, 8 bits equals to 255, right? So you have 4 of them, okay? Now, that seems like a lot, right? Uh, so, but you need many more when you go into, let's say, the Internet of Things, right? So that's why you have the V6 came along, which goes for 128-bit addresses, where IPv4 only had 32 bits. So this is a key point. Try to remember this part here. Okay, so this is really the big win when you go to IPv6 is this. Okay, you get many more addresses. Okay, and let me see here. Here. All right. Basically this is just trying to kind of draw an analogy to you having your own address for your IP, right? Internet address. Okay. So there's different sections to this. So you might see this, right? For example, Rutgers.edu, right? So you have these what they call top level domains, right? So I guess traditionally or historically, these are common ones, right? So you can say these are kind of like for a long time, right? So edu for like universities like Rutgers, com.com is for like companies. So you might remember or know of like what they call the dot-com era, or the dot-com boom and bust. So in the early days, any companies basically start off with .com, right? Uh, you have this like .org for organizations. So they're kind of like maybe charity organizations and stuff like that. Um, and then you have like .net for networks, the mil for military and government, right? Now, like I said, these are what they call top level domains, and they've kind of been like there historically or for a long time traditionally. Um, but you can see, like more recently, they've been adding more to it, right? So expanding the possibilities again because the popularity, everybody has been growing their presence on the internet, whether it's the Internet of Things or different organizations or customers and stuff like that. Um, so you can see whether it's these different types of things like this or countries, right? So Canada, UK, France, so on and so forth. Okay, so this is all an effort just really to expand the scope here. Now here's like a typical address, let's say. Okay, so you can see the end part here, the top level, that's your .edu. Okay, uh, you have this HTTP. That's kind of, as I say, the protocol. You'll see actually a lot of things now, especially when you go to commercial type of sites, it'll be HTTPS, right? It's meant to talk more about like a secure domain, so it's more from a security standpoint. So most often when you talk about e-commerce and stuff like that, but even beyond e-commerce, you'll start to see more of HTTPS, okay, as with security, okay? And then here, this is like kind of like you have the top level and you have like these sub levels, and I'll get into that in a second. So in this case, you're talking about CS for the computer science department, and then the next level up would be the University of Washington, right, which would be this part here, right? And then again, remember EDU is your top level domain, okay? All right, and the next couple of slides will kind of visualize that for you a little bit. Okay, so you can picture like the EDU at the top level is like this big cloud. There could be a whole bunch of different .edus, right? Rutgers, Washington, Princeton, whatever, you name it, right? There's a whole bunch of them. So the biggest cloud, the biggest portion would be the EDU. So that's like this green part here, okay? And then within that would be, let's say, the different universities, right? Right? But then within universities, obviously, there's different departments and whatnot, right? So in this case, you drill down to a next level, then you have this with the Astro, and then you have this within the CS, right? But then you want to drill down even further to, let's say, the specific computer or specific address or machine or whatever, then you get into that, right? SPIF and tracer, okay? So let's look at this more in a this looks almost like a org chart to me, right? But I guess they'll call it a hierarchy, okay? Again, top level domain, remember this, right? Boom, 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 right? So that's all the way on the right-hand side, .com, .edu, and whatnot. And then here, remember that's the next level down on your cloud, right? And then this is your sub-department here, right? And then this is down to your specific machines here, okay? And here, this is the idea of like domain servers, right? And this is, you draw an analogy to like in old days, they have the phone book, right? So remember we said like you would type in amazon.com, or in this case, spiff.cs Washington edu. You're not going to memorize IP address, okay? So it's basically a mapping of this to this. That's what these domain name servers do. So when you type this in, it knows that this is what you actually mean. And it'll go to this machine, let's say. Okay. And here we have the local area network and the wide area network. Okay. So basically you can kind of talk about the local area network being, let's say, around like the computer department, right? local area, right? That's why they call it a local area network, right? The wide area network would be something that encompasses, let's say, you're talking to other universities, you're in North America, whatever. Um, it's basically higher level up, okay? And basically it's consisting of these other local area networks that connect into a wider area network. So TCPIP, this is what I mentioned before, where I might not send a file, well, I want to send a file from point A to point B, but that's not actually how it goes over the network. It gets chopped up into these little packets and then gets over the network through various number of paths. And then when it gets to the destination, it gets reassembled back into that file, right? So I start off with a file at point A, gets chopped up into all these little packets, and then it goes to the destination with its path. At the end, there will be something that collects all of that together, puts it all back together in the right order, right? So you can recreate the file, right? So the protocol for all that to happen is called TCP/IP, okay? Um, and so this is just trying to draw the analogy by sending your novel to the publisher using postcards, right? So you can see like number one, chapter one, right? And then there'll be probably something else that'll say like number two, chapter two, right? Something to that effect. And that's how you would piece everything back together. So Ethernet, that's basically the actual physical network, okay? So this basically talks about like when all the computers are connected together, what is the protocol that they use to talk to each other? Um, so in this case, you're talking about uh, like one computer is sending out and uh, every other computer pauses to listen to what this one computer is saying, right? So it's basically a structure so that the computers can talk to each other. Okay, so this just draws a picture of, you know, how on the bottom part, this is how like it might look like from a university level, right? So here's your campus, here's your local area network on your campus. Uh, it goes into this internet server, into the gateway, and out onto the internet. For you at your house, you have a modem that's going to connect up into the internet service provider, let's say Optimum or something like that, and then into your internet gateway and into the internet. So that's how you can look at a difference between what you have versus like what might be the setup at the university. The obvious difference really being the local area network. Okay. So wireless, you probably do it like at Starbucks, whatever coffee shop. Rutgers has the wireless. So basically, Wi-Fi, this is the protocol on how it communicates, 802.11, and you connect via a router, right? And the router connects to the internet service provider's modem, which connects to the internet, right? You probably have it at home. You probably have like a router. Your internet service provider comes into a modem. It connects up to your router, and then you have your own personal Wi-Fi around your house, right? So similar type of thing, okay? Uh, so yeah, same thing, right? So remember what I was saying? Here's your modem from your internet service provider, comes into your router, like Netgear or whatever, right? So that becomes your Wi-Fi. Um, this might actually be wired to your computer, or it might be Wi-Fi. Same thing with your smartphone and your laptop, okay? Um, and these are all of the stuff that we highlighted at the beginning. I think we should have covered all of these different points here. It's also covered in your book. So run through all of these, and just let me know if you have any questions on any of these. These have not been explained clearly. I'll try to pick it up in another lecture. All right, thank you.